Hello and welcome back to a new video in my scripting series. We are still doing Java, or actually last video we just started Java. We loaded Java and we also created a project in Eclipse, and today we're gonna initiate a Java VM and actually load our file in there, so stay tuned. Alright, to start creating a Java VM, we first need to actually include Java. We're gonna include Java by including the JNI, the Java native interface, as it's called. So if you take a look in here, it provides some Java types like a int, double, float, short, char, boolean, some objects, some classes, throwables, strings, arrays, boolean array, byte array, char arrays. Several like Java classes and pointer to Java objects, and some wrappings so that we can actually easily create objects and interact with Java, because the interaction between Java and C++ is quite rich, even through not very well documented. I mean, yeah, it is kind of like documented, but it's kind of like a very, very old and very hard to read documentation, which doesn't explain many stuff. And so you need to do a bit of research to actually get into how this all works. But yeah, that isn't of big of an issue. We're gonna get to that, and yeah. So basically you can see this is just it's basically a C++ wrapper of the C API. So you see it's actually checking if it is C++, and then it is like adding functions to the struct here, which actually like call the actual pointers there, so you can easily use this as functions and stuff like that. So yeah, basically this is the Java native interface, which is doing all the magic. So first of all, we need several members for Java to work. First of all, we need the Java virtual machine, so the Java VM, which is just a pointer to the virtual machine, which is my pointer Java VM. And this is gonna start as a null pointer. This is kind of like the VM. There we can say load the VM, and we can say shutdown VM. It also handles stuff like attaching and detaching threads, but this is more advanced. We're just gonna have this as our VM, our Java VM container. Now, to actually interact with Java, we need a JNI environment. Is it called a JNI environment? Yeah, JNI env for JNI environment, my pointer Java environment, or I just call it Java env because it's shorter. This is our environment. On this environment, we can actually say check for that class, load that function, and stuff like that. So basically, this is our Java environment. So the first thing we are gonna do is we're gonna initialize this VM here. So basically the first step is init Java VM. VM stands for virtual machine. So we say JNI create Java VM, because we wanna create a Java VM. First of all, we need a pointer to a Java VM, which is my pointer Java VM. Then we need a pointer to an environment as a void pointer. So we convert this, and this will be our environment pointer. Next thing are arguments. These arguments are actually special arguments. They are called like VM arguments, Java VM init arguments. I think is it that Java args. Let me just take a look if these are the right arguments here. Yeah, these are the right arguments. So we're gonna have the Java arguments. I'm just gonna copy this here and put it in there to actually like call this Java VM, and this Java VM is actually returning an integer with which indicates if it succeeds. So I'm saying if that call is equal to JNI OK, which stands for operation was OK, which means GVM has been initialized, then I'm gonna continuing on with my stuff here. So now we need to populate these Java args. Let's take a look at them. First of all, the Java args has several options here. First, ignore uncategorized, which is being set to false. Honestly, I have currently not that big of a plan what this is. This field there, it's just set this to false. So yeah. Then we need to specify a version. So we're gonna have an JNI version 1.8, which is the latest version that is available in our JDK, which is okay here. And we need to set options and number of options. First of all, the number of options will be 1. because you need to supply one option, and this is the so-called Java path, the class path, which actually tells Java where our jar is located. And then we need to actually specify some options, and they are called Java VM init. Sorry, where is the type? Yeah, there it is, Java VM option pointer. So it's an array of Java options. We are just gonna need one, so we need Java options, Java VM options. There it is. And this will be our jar option, our jar path option, and this will be so Java option, and this will be gonna plugged in there. And if you take more of them, you could make this an array, for example. Maybe let's do this. Let's straight away create this as an array and call them options, so that it's a bit more clear. If you want to have more, then we could actually use a count of helper here. Where it is, count of. There's the count of helper, but where is the real count of? CRT count of. Yeah, then just use the CRT count of. I'm okay with that. Yeah. So basically this is just counting if how many elements are in there, and so you could put in several options there. You could also make this with preprocessor constant, but we are doing this like that. Now we need to actually describe our options. Maybe just call this jar, not jar, actually now Java options, then it's a bit clearer what this is. No, I don't want to build, but I press build. Yeah. Now we need to populate the informations here, so we're gonna say Java option 0. We have some extra info here, and we have an option string. We need to populate them. So first of all, the option string is a string of options. I can't use a direct string because a direct string is a const char, and this actually expects a normal char. I don't know why it's not modifying that, but yeah, that's just how it is. Let me just leave this for now here, because we are doing this differently anyways. Extra info is not gonna be used, so we're just gonna set this to null pointer. And what's your issue there? Because it's not initialized, so we could maybe initialize this to 0 there. Okay. Now we actually need to build this option string, and so I'm gonna say build Java jar location, because this jar location needs to be specified. We're actually going to do this with a std string and an std string stream here. So I'm going to include string and string stream. There we go. And I am going to say std string stream ss. And we're going to say we want to set the djava class path, which is the class path of our Java application. And this is gonna be set to our run path, and we will append our Java name, our jar. So we had this called hangman.jar. So I'm gonna copy that and just paste in hangman jar there. Now we kind of like need to get this again. So I'm gonna say std string option 1 string, and I'm saying ss string to get the string from the string stream. And now I could just say .data, which is returning a const char. Is that what was the function to actually get a modifiable buffer? Was this at 0? Is that returning? Yeah, that's returning a char. So we do this like that, and then we get our modifiable string here for Java. So now we need to kind of like get this run path, and we actually use the Windows functions for that. So we get application directory. So I'm saying char app directory, which is just an array here. Maybe let's do this 2049. And I'm saying get module file name, because we want the file name. A, because we want to have the file name for ASCII string. The module will be get module handle, which is just retrieving our current module handle with a null parameter. We're gonna put this into app directory, and the size is 4094. There we go. And now we need to actually find the last backslash there. and this is easily be done by calling the special function. First of all, let me do this like that, so that we are like that. So char last slash, and this last slash will be equal to char. Let me include the C standard lib first. Or maybe it's C string. I think it is in C string. Yeah, there it is. We need the str char. So double R string R char R. This function is required. We're going to look for the app directory, and we're looking for a backslash because Windows is working with backslashes. And what we then say is we say last slash at position 1. So the next character is the null terminator, which basically cuts off the character or cuts off the string after the last slash. And now we can actually use this app directory here in the string stream as our run path to get a direct path to our directory there. So yeah, that's how it works. But of course, when we initialize the Java VM, we also need to make sure to release that Java VM. So I'm gonna add a destructor here. So Java VM, Java game, sorry. The Java game destructor, which makes sure that the Java VM is cleaned up properly. Let me get this here, there we go. And we're gonna say if my pointer Java, oh, I called this JVA, so let me rename this. Just a typo there. There we go. So pointer Java VM, if the pointer exists, we say release Java VM. We're gonna say my pointer Java VM. How is it called? Destroy Java VM, which basically just destroys our Java VM. Destroy VM. Let me maybe add a return statement here so we can put a breakpoint in there. I'm putting several breakpoints in there that we can actually see how it's working, and we're picking a breakpoint here, a breakpoint here, a breakpoint maybe here, or even there as well. And now we can actually test this. Let me start this and hope that I've done everything right. We're gonna select Java here, and you can see now the app directory here is totally empty. But as soon as I continue the execution, you can see that we get this string which directly points us to our exe. Now when we find the last char, we actually get a pointer to this backslash and game invoker exe. And now I'm actually replacing that, and you can directly see that now the path is ending directly at the current directory. And now after this runs through the string stream, we can actually see that our string here, our std string, is the Java class path and then the path to our hangmanscript.jar. So this is working correctly. Now let's see if our options were configured right, and we get to the construction of our Java VM. Maybe put a breakpoint here as well to take a look here at the Java arc. So the version is correct, or I suppose it is correct. Is it? Yeah, probably is correct. We have the n options is set to 1, which is also good. We have our option in there, and we also have our false there. So Java VM should return true, but it doesn't. It has an exception, and it says a frame not a module. It will say if you're in an English system. By me, it's called saying ramen is not a module. Actually, this is supposed to happen because Java is doing something to check if an AVX instruction is possible. So it actually writes and reads at position 0x00, which is recognized as an error here in Windows. But we can fix this by going to the exception settings, opening up the Win32 exceptions, and we are gonna look at a access violation here for C0005, because we get here a C00 whatever 5, and because this is expected, we can just simply remove this checkbox here which says don't break if this exception occurs, because this is not an exception. I can continue, and you see this function succeeded, and we are at this return value. If we take a look at the sys pointer, our Java VM has a proper pointer, our Java environment has a proper pointer, so this all works. It is just supposed to crash there. And you can also see, like, that our memory has gone up exponentially to 1.8 gigabyte. I may need to take a look at that because 1.8 gigabyte is a bit much. I don't know if this is actually because Java allocated heap. It could probably be, I need to recheck this, but it probably is right. So let me just continue execution here, and we see we directly fail here. Maybe let me put a breakpoint here to the destructor here as well. Or we directly close again, and when we now rerun this, we shouldn't get this issue. We should directly... What? Hasn't called the constructor? That's a shame. Why hasn't it called the constructor? The destructor, sorry. Ah, yes, I know why. We need to make the destructor virtual because we are creating a interface here. You see, this is an interface. And on an interface, it's very important to make the destructor virtual. So we're gonna create a virtual iGame destructor here. So make this a destructor, but not pure virtual because it's not required to have a destructor. So just make a virtual destruct here to make this build. So there we go. And now I've got rid of the breakpoint. Let me put this again there. Now we should call this breakpoint. There we go. Now we have the breakpoint here, and we would go in there and we would correctly destroy our Java VM there. It's not going to be unset here, but yeah, we destroyed here our Java VM. And now we kind of like have Java integrated with our application. So basically, Java is now up and running. We have an instance of the Java VM running in our process, which was loaded from this JRE directory inside our application, and it already loaded our hangman script.jar. And we're going to actually verify that this hangman was loaded. Let me just quickly open up Eclipse here again to actually get the package name. We're gonna check that it is actually loaded. This is just a simple check if jar was loaded. Okay. So what I'm gonna do is I wanna retrieve J class, which is our hang class. Maybe we need to adjust this and add a function there. I don't know how strict Java there is, but we can actually, yeah, we will see. And we will now call our environment, and we ask our environment to find a class, and we need to supply a class name. The class name is the packet. I think we called it, how we called it, game Java hangman, I think it was called, but let me just verify this. Game Java, game.java. I mistyped this there again. Where's refactor? There we go, rename. Let me export this again. There we go. Game Java hangman hangmain. So game /java /hangman /hangmain. And this should give us, in case we have done everything right, a valid JClass object. Let's test this. Just take a look at this. And the hang class is null, which isn't that good, but we can fix this without an issue. Okay. I know where the issue is. It has redirected us back to Java 16. I don't know why Eclipse is doing this, because I have adjusted this several times, and I had the same issue when I tested this Java stuff. Maybe let me just completely get rid of this again. It has done this again with Java 16 and not 8. So we're gonna go to our hangman script, properties, Java compiler, and we are setting this to 1.8. I don't know why this is always defaulting back. It's always defaulting back to our different stuff here. I don't know. So let me build this again. Okay. My file is still being used by a different process. I am still on debugging here. No, I'm not. Ah, okay, because 7-zip is open. So in case I close 7-zip, this should export without an issue. There we go. Yeah. Let me now check if now our C++ framework is doing that. Let's go to... I haven't changed anything. Just because I've pressed like F5 and 7 at the same time. Let me just try again. B and now we should get a proper Java class. So now you can see the hang class is a proper object. It is a J object and it has something in there. So now we kind of like have no issue there. This was just because Eclipse was exporting this wrong with the wrong Java compiler, which of course fails when we wanna load that specific class. So yeah, basically this says that everything works, and in the next video we're gonna continue on with writing a bit of a Java framework and then writing a bit of a C++ counter framework to actually link our two applications together. So I hope you enjoyed, see you in the next video, and bye!